This tutorial is about solving compound inequalities. So here we have an example so we can figure out what this is. We have a popular theme park that has weight restrictions for safety. On one ride, riders must weigh at least 40 pounds. That sounds like an inequality, but no more than 250 pounds. All right, so the inequalities that you would write for these, at least 40 pounds would look like this. The weight is at least, meaning you can weigh more than or equal to 40. And no more than 250 means that your weight must be less than or equal to 250. So I would turn around and, since I've broken these down and both of these go with this problem, okay, I'm going to graph each one of these. So greater than or equal to 40 means that that will be filled in because it can be equal to. Less than or equal to 250. So I'm going to say it's right about there, 250. All right, so greater than means I'm going to go this way. Less than means I'm going to go this way. Okay, so this makes it a compound inequality because they intersect each other. Okay, now let's keep going. A compound inequality is where two or more inequalities that are connected by the words and or. All right, so we're going to do another intersection. This up here was an intersection because they collided in the middle. So here we have this intersection, but we don't have a word problem with this one. We have simply -5 is less than x minus 4, which is less than 2. So I have to find the two inequalities in here. So break it down. -5 is less than x minus 4. There's 1. Okay, so I'm going to write that down. -5 is less than x minus 4. And I have, going this way, x minus 4 is less than 2. All right, so there's my other inequality. I'm going to write that down. X minus 4 is less than 2. Now you solve each one, okay? And you're going to then graph those solutions. So I'm going to add 4 because I need to isolate that x to both sides. -5 plus 4 is -1. There's one inequality. All right, add 4 to both sides here. Isolates x. 2 plus 4 is 6. All right, now this one is not facing the way we like it to face, so I'm just going to flip everything around. So x is greater than -1, and x is less than 6. All right, so if I make a little number line here, 0, 1, 2, 3, 4, 5, 6. We're just going to go 2, 4, 6. Whoop, and then we do need to include that -1. I'll go this way. -1, 2. All right, so x is greater than -1, so that means it's going to be open, going this way. X is less than 6, again, open, going this way. That's where they intersect. Okay, so any one of these numbers in between these two are solutions for this initial inequality. All right, now they also have a compound inequality that's called a union. Let's see what that means. Okay, so I have this inequality and then I have this one. And again, I need to solve both. So I'm going to solve for h. So subtract 4 first, because remember you're undoing order of operations. I'm left with -3h is greater than 15. Divide by -3 on both sides. So h is less than -5. All right, over here, I'm going to add 3 to both sides, left with 7h greater than 21. Divide by 7 on both sides. H is now isolated and it is greater than 3. All right, so again, create a number line, and we're going to go 1, 2, 3, 4, 5. Negative 5 is way down here. And 1, 2, 3. 3 is way down here. All right, so H is less than negative 5. Ooh, guess what? I divided by a negative, so this thing, if you don't forget, has to flip. So I have to flip that this way. All right, so now H is greater than negative 5, so that means it's open. So it's going to go this way, shaded. H is greater than 3, which means also this way. Okay, so notice they're going both in the same direction. So all of the points for here also include all the points for here. Okay, so the solution set is H is greater than negative 5. Okay, all right, I hope that helps.